Now, this illustration gives a full illustrated outline of applying terminals at 60 or 75 degrees C based upon the terminal ratings being 100 amps or less or over 100 amps in accordance with 110.14 C1 little a or little b. Now notice the note at the very top of the illustration says all conductors are THWN, copper conductors, running conduit, meaning we can take the 90-degree column ampacity to derate from. Now, the next note at the bottom says terminals are not all 75 degrees C in each circuit. Therefore, if you're 100 amps or less and they're not identified 60/75 or 75, then there's 60 degrees C ampacities that we would have to use in accordance with table 310.16 shall be used. And then we tell you, now if you want more information on this in greater detail, more understandable text and everything, the figure loops is see figures 8-4 and 8-11. Now the NEC loop, the temperature we're looking for is 310.15A1, where we don't overheat the copper conductors or aluminum conductors, copper clad, to cause insulation failure. Terminations now is 110.14 C1A and B. A, the equipment and the devices and terminals are 100 amps or less. B, the terminations, overcurrent devices are forced over 100 amps. The D rating now for adjustment factors is 310.15 C1. For correction factors now, we would move over to 310.15 B1. So we get these rules there. And then our table 310.16 lists the ampacity of a THHN conductor based upon its size and its material, copper, aluminum, whatever it may be. The loading now is 310.14 A3 exception, which is important to review. Now, with all this information given, let's look at circuit number 1 in the illustration. Circuit number 1, look at the equipment first. 60 degrees C terminals, meaning we can use and have to use the 60 degree column for ampacity after we derate, if that be the case. Now, in the equipment itself, for that circuit 1, we're saying it's a 60 degrees C column in accordance with the outlined requirements in 110.14. C is in car 1 little a along with table 310.16. So we have a number 8 conductor, and if that was on, say, a 40 amp device, that's 100 amps or less, then we could have a say number 8 conductor going over and feeding that, and we would have the ampacity that we needed, if my memory serves me correctly, in accordance with table 310.16. It's 100 amps or less. Now, let's look at the circuit 2. The overcurrent device is over 100 amp, and the equipment is 75 degrees C terminals, 150 amp calculated load, so we'd have 150 amp overcurrent device with 1/0 wire feeding that if we didn't have any derating factors, and so forth. Now we're looking at these circuits as if they're in paradise. There's no correction factors or adjustment factors that we learn all about if you read chapters 8 and 9 in volume 1 of Stallcup's electrical design book. If you care for more material to look at and more detailed explanation given. Now note 3, notice we're 60 degrees C terminals at the equipment, 100 amps or less, but back in the service equipment we're 75. So the complete system is not 75 at the equipment and the breaker, so there's 60 degrees C terminals that we would connect to. So this is where, if I'm an electrician, I'm looking at the terminals, at the equipment, service equipment, or sub-panel, and then I'm looking at the terminals of the equipment, and that would let me know which terminal rating that has to be used, service equipment or at the equipment. In the circuit 3, it's at the equipment, see. And you notice it says 100 amps or less, conductor sizings 14 through number 1 in accordance with 114.C1a. Why is that? Because if you're a 60-degree C terminal, it takes a number 1 conductor to give you 100 amps. So that's why it's number 14 through number 1 in 110.14C1a. However, if you had, say, the equipment was 75-degree terminals in 3, and the overcurrent device area of terminals were 75-degree C, I could use a number 3 conductor in the 75-degree column for 100 amps. So that's the reason that you have number 14 through number 1 as a 100 amp or less type conductors. And then when you're over 100 amp, you really have to get with the inspector on this, because they may require, if it's over 100 amp device, 1/0 wire or larger. This is a call of the authority having jurisdiction, and a lot of them will give you the grace and let you size according to whatever you calculate. But others may not. They say, look, 110.14C1A, number 14 through number 1. If you're over 100 amps in rating, you're 1/0 or larger, and they'll hold you to that. So if you get into that situation, be sure you check with the authority having jurisdiction, or you may be rerouting and repulling conductors, and your conduit may even have to be upsized. So this is just a warning for you to remember these terminal ratings at 100 amps or less, or over 100 amps, with the NEC loop giving you these particular sections in accordance with the particular section that regulates correction factors, adjustment factors, loading, whatever it may be. And that's what our figure 14-15 B1 is illustrating.